we're recording.
Okay.
I think it's very helpful as well.
So when we're done, let's go ahead and talk about our final project. It looks like I've got take action.
To make inference and take action. Yeah, we got to do that one. And yes, Cheryl, you're right. It's very stressful when you know everybody else's
grade. And yeah, we've got, this is worth 25 points as well.
Right. So I looked at how much it really affected our grade, and it really didn't.
No, it didn't. I was surprised it didn't go up at all.
6 point something. That's the weight. 6 point.
I know, which is nothing. It's a lot of work for nothing.
Yeah, that's how I feel about a lot of my classes.
That, you know, like what, 60% of the grade are the tests. So even if you passed everything and failed all the tests, you would fail.
Yeah.
That's a comfort.
It's a comfort to know we're not there. We're gonna make it. We only have one more week. We can do it. Oh.
This was a hard semester.
Amen.
I agree.
Yep.
So do we want to talk about the final project before we begin the quiz and see which standard do you want to do the quiz and then work on the project?
Quiz done. I just want to get that done because that could take a long time.
Yeah.
But the quiz?
Yeah.
Okay.
Well, and it seems like it's just a lot of reading the data and interpreting the data.
I'll click start and see what it is. The only thing, when I was going through the lesson, the only thing that I didn't find was when they were talking about, like under 4.1, it had the unstandardized coefficient, and then it said standardized coefficient beta 0.990, and I didn't find that anywhere when I was using the linear regression.
Which one are you looking at?
The just the assignment or the
what number?
Homework reading. It's number 4.1.
4A, state the null and alternative hypothesis?
Yeah, it's hypothesis test for regression coefficients, and that says 4.1, and it talks about crocodiles.
Right.
You want to know if there's a linear relationship between X and Y.
Right.
And then it gives you the box and it shows the coefficients. But I never found, I found, you know, putting it into the linear regression, the unstandardized coefficients, and I can make that match. But it nowhere does it show a standardized coefficient. So I don't know how in the assignment as you went through it, why it was there when I couldn't find it anywhere.
I see what you're saying. It is different.
And then it talked about SIG, and it talked about ANOVA. The p-value was given under the SIG column of the coefficient table. And I'm like, what was that? Because I never found that number either. So I don't know if we're going to need it or not.
Didn't they used to use a different software? I wonder if that's from the other software.
Yeah, the SPSS or something.
Yeah, because I wasn't finding those things.
I don't remember any of this, Cheryl.
It was just when I went through and read it. I read it again this afternoon at work, just when I had a minute to just try to go through it again and see if my numbers match their numbers.
And that was for number 4?
Hold on. I'm trying to load. I should have went into the quiz before, like at 7:30 when I first turned on my computer. Because by the time Excel loads, it takes forever. Well, they took the wires out of my back today, and my back feels better.
Oh, good.
Hi, cutie.
Next Friday, they put them in permanent because it really does help. But
That's
I
okay.
told him, I
I'm
said,
gonna
am I gonna feel like you beat me up for 3 days again? And he said, yes.
But did it really help?
It did, because there were nights I didn't wear the device, and I woke
Okay.
up and I could hardly walk in the morning. And the nights that I did wear it, I could get up and I had no pain. So it definitely
Oh,
worked.
good. Hey, you're gonna do our work for us? You gonna do the test?
You gonna help?
I bet he has all the answers.
How old is he?
He's 2.5.
Oh, cute.
Totally cute. I'm gonna be a new grandma too. Number 9 coming in June.
Number 9. Oh my gosh. I've only got one.
I'm excited. So I'm just waiting for the other Excel to open. We're almost there.
All right, hang on. Let me get there.
I know. Excel is so slow.
Ugh, I gotta get these downloaded.
That's why I said I should have went into the quiz before we ever started and got all this stuff downloaded.
Yeah, I was going to do that, and then I started reading all the stuff for the project, and
That's how I was last week. I got sucked into that project mode, and I was like, and I'm sorry, I really thought it was my week to do it.
Well, now you can relax.
It's okay,
Lydia
because
gets-
next week when we do our final, I'll do my final on Wednesday, which is my birthday. So,
Oh, happy birthday.
to you. Yay, what a way to celebrate.
I know. I'll celebrate when I pass the test and know that, I held on to my B for the semester.
I don't
And I'll
know
be
if I
happy.
have time to take that test. I'm just going to have to tell him I don't have time.
Well, I have
Is that
Wednesday
okay?
off I always take my birthday off, so I have the day off.
I'm trying to finish my portfolio for the practicum this week also.
Oh,
Oh, I am
This is
looking
me
forward to
out.
that. I'm taking that next semester.
Who do you have?
I don't know. I don't remember who I have. I have it written down. It's somebody that I don't think it's the same person you have.
Okay,
I don't remember who it is though.
somebody. That's who it is.
Mm-hmm.
Hey, what happened to Lo?
did she
Hmm.
disappear?
Yeah.
I'm sure she'll be back. If not, I'll invite her back.
I forgot to ask you to get windshield fluid. We have a 2005 Toyota. My son hates it right now.
Why?
He had to take the alternator out, and he's like, "It's stupid."
He wants to take the
Excuse me.
alternator out?
No, he did. He did. It's just not an easy. It was not very easy to get it out. So he's like cursing Toyota right now.
Hmm. I can't get Excel to open.
We're just doing a t-test. I wonder what happened to Lo.
Should we text her?
I was working on that.
Should I just send her back an invite?
Mhm. Mhm.
All right, you guys ready to read it? Number 3.
Yeah, I think I
Yeah.
got one of these pulled up.
3. Is 3?
Okay. True
That's what I was
linear.
wondering. Is 3 3?
That's what I put. Because you don't know what the numbers are, so you don't know if it'll be greater or less
Less
than. So it's
Right,
going
and
to
they're
be equal
usually-
to or not equal to.
Yeah, they're usually 2 different numbers, and they're not usually equal to each other. But the
Mhm.
all does need to be 0, like equal.
Mhm. Yeah, it always is. Isn't it?
Correct.
Yeah.
That's what we always do. I learned that the hard way.
Okay.
Okay, a residual is the difference between BO and B1 or B naught and B1.
Except
Right?
for there's
Residual
also
is the difference between
S
the
or-
observed value of y and the value predicted by the regression line. It
Yeah.
says that at the top of 3.2. The residual is an observation is defined as the difference between the observed value of y and the value that would have been predicted by the regression line.
Yep.
Oh. So that's 3?
Correct.
Is the difference between the observed value y and the value predicted by the regression line.
It's right at the top where it says 3.2. It says residual.
Okay.
It's been word for word almost.
Okay, great. But isn't it B naught mine and isn't it the difference between B naught and B1 as well?
No, because there's 3 parts to the equation, and that would only take care of 2 parts. But the observed value of y and the value predicted by the regression line, because that's the entire line.
Okay.
Okay. She's trying to get back in. Okay, so number 5.
What did we all do before texting?
I know.
Oh, cool.
Made it very difficult to have 2 conversations at once.
It was just, I remember when there was just an answering machine. And cell phones.
The kids see the corded phone and they're like, how does it work? I'm like, where's the send button? I don't know where the call button is.
I found one of my old dial phones. And my daughter was about, I don't know, 8 or 9 at the time. And she's trying to push the holes. And I go, no, you put your finger in it and you move it. She goes, that was so weird. And I go, well, that's what we did.
I was talking about party lines when I was little, because where we lived, it was still very rural, and we had party lines. And I'm like, what?
That's funny. And you could make an emergency phone call to anybody at any time.
In the small town that I lived at when I moved here, we only had to use the last 4 numbers of the phone number. It was crazy.
And the directions were, you go left 3 streets and right, and there you go.
That's right. There's a tree and then there's a rock. And
There, you kind of turn left there, and then you'll see a tree stump.
that's exactly how it was.
We're dating ourselves.
Yes, we are.
Yeah. Already done. Things have just progressed so quickly.
Too quickly. Sometimes it's not a good thing.
High school, we had floppy disks. You don't understand.
Mm-hmm.
Yeah.
Well, I remember 8 tracks.
Me too.
Yep.
8 tracks.
And I had one of my first 8 tracks. I had Foreigner, and oh gosh, what's the name?
I love Foreigner.
I can't think. There was another one. Oh, what's his name? Peter Frampton. I had yeah, the old days.
Then you get the cassette tapes and use the pencil to rewind it.
Yeah, we had to twist it around on the pencil because it would always get eaten in the cassettes were always getting eaten in the car stereo.
Yep.
Okay, let me make this bigger so I can invite Lo back.
Yeah, she wants you to invite her again.
I know, but I always gotta look up the which email is hers. Is she illuminating? I think I ask that every time. Yeah. Send. All right, there.
Hi, sorry.
There she is. Okay.
Where are you guys at?
We
5.
stopped at 5.
Okay.
So we had 3 is 3. And
4 is 3.
3.
All the way down.
And then we left off at 5. A plot of residual support using linear regression when you see a pattern in the residuals.
Well, it says this was it. Oh, it talks about the one above it. Unstandardized.
Or the residuals look normally distributed. Let me see. I'm not sure how they have that worded.
Because the megaphone is not good.
No, it's no bueno.
Residuals are all positive. Residuals look normally distributed.
Or you see a pattern in the residual. That's what I was thinking, but I'm not sure how it's worded.
Well, it says requirements, though, for a linear relationship. The plot of residual supports using linear regression. It says on the requirement summary, it says linear relationship, scatter plot, hot dog shape, residual plot, no pattern in the residual.
Right. But that's the linear relationship between X and Y.
So this says the residual plot shows random scatter. There's no obvious pattern in the data. If linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter.
Then it would be a megaphone.
And that says if there is a pattern in the residuals, it suggests that linear regression is not appropriate.
So the question is a plot of residual supports using linear regression when?
That's not something that's distributed normally.
Yeah,
Well, that doesn't make sense because when you read that same thing that Lo, I think, was just reading, it says it's talking about the scatter plot. And it says this residual plot shows random scatter. There is no obvious pattern in that data. If linear regression is appropriate, then the residual plot will show no pattern and will consist of random scatter. Let me go back.
So if linear regression is appropriate, then the residual plot will show no pattern. Okay, so if linear regression is appropriate,
I think the only one it can be is the first one.
They go back to normal distribution quite often.
Right.
That's what you want. You don't want a megaphone shape because that means you did something went wrong.
Mm-hmm.
Because it says scatter plot. I'm going to go back to scatter plot because we're talking about plots. It says, to check requirement 1, we need to do 2 things. The first is to make a scatter plot and to visually check to see if there is a linear relationship between x and y. This has been referred to as the hot dog shape in the data. We want to make sure that there is no distinct curvature or other nonlinear characteristics. This is simply a visual check of the data.
Right.
I think A is the answer. Based on that.
Yeah, that's all we can.
Let's
Okay,
pop these
so-
numbers in.
So math self-efficiency, I haven't even looked at it yet.
I know math efficiency.
Okay, so we have 2 scores to work with. Does it in which spot?
It doesn't matter what is x and y.
Says
What does that mean?
confidence
Does it-
variable as the explanatory variable and score variable as the response variable.
So the second one will be the first, right?
So the confidence is x.
They do that on purpose.
Throw you off.
And then the score is y.
I need a much bigger screen. I'm lost.
2 screens.
Yeah, at least. That would be awesome. Like one of those ones that you see on TV shows where they just look up and you can use your finger and move
Yeah.
stuff around. And I don't even know if those exist.
They have to somewhere.
Somewhere.
Okay,
So at work, I do have 2 screens, and the kids think I have all these computers. Like, why do you have so many computers? Like, they're just screens, guys. Got asked today why so many people are born in December.
You know, I don't
Did you
know.
figure it out?
Summertime is warm.
You can find a lot of people in a lot of months.
My daughter was born in December.
You figure my kids were born June, July, and August. So you know what I was doing when it got cold. I don't like the cold.
That might have been a good statistics assignment.
That could have been.
You know, in what month are most people born according to whatever? I'm still putting mine in. Sorry.
It's okay.
I had to close down my Excel and open it again.
I did that how many times last week?
Yeah, is your computer working okay now?
Yeah. I think it was user error. I don't know if it really is or not. But
It just didn't want to work.
yeah, because I fought with it like crazy last week.
Okay, so where are we at right now? I got everything.
Goodness gracious.
Bless you.
Thank you.
Okay, compute the residuals for the data using software. What statement best describes the residuals? Oops.
Not one.
It's linear. It's not negative.
Yeah, it's
Nope.
not 3.
So we're going to go with 2.
So I go with 2.
Yeah, look at the scatter plot. It's linear.
Yeah.
Wait, I didn't say 4. Let's see. That was 3.
Okay, so I didn't do the QQ plot, but don't you think they'd be normal?
Yeah, fairly
I
normal.
think they'd be normal fairly. Oh, I highlighted these 5 assumptions so I wouldn't. So, number 8, the 5 things are, there's a linear relationship between X and Y. The term E, well, that's not on there. The term E is normally distributed. The
Well, it has the
variance,
variance of the error term is consistent.
well, the next one is, number 3 is the variance of the error terms is constant for all values of X.
Guess what? Ours are all mixed up. They're all different.
The next one is the X's are fixed and measured without error. And the observations are independent.
So all of them.
So do you?
Well, I didn't read the error term B.
Yeah, because the first one, the linear relationship between X and Y, that's the very first one. The variance of error term is constant for all values of X.
That's number 3.
Which is number 3. And the residuals are normally distributed. Which
That's my number 3.
Right, that's number 3 in the line. But sorry, I gotta sneeze.
Bless you.
Sorry. So what does the E stand for? The random variable, we can start with the Greek letter E.
It's epsilon.
It's a normal random variable.
Right, so that's what I'm saying. So number 2, 4 of those read exactly how it is. The residuals are normally distributed. That is not one of the 5. It says the error term, the epsilon, is normally distributed. That is not the residual, is it? The epsilon, is that the residual?
Residuals plot, half should be above and half should be below the line. So, because it's a residuals plot, let me see.
You know what I'm saying? So all the other 4 read exactly. The third one, the residuals are normally distributed. If the residuals are the term error, then that is correct. Because number 2 says the error term epsilon is normally distributed. So if that's what the residuals are, then it's that one as well.
So you're saying it's all 5?
Well, we don't know because your classic linear regression is y not or b naught plus b1 plus epsilon. So epsilon is not the residuals because that's included in that's y. Y equals b naught plus b1 plus epsilon. So maybe 3 is
Well,
not checked.
on 3, it has the error term E is normally distributed.
Right. So that doesn't
But it
say the
doesn't-
same thing as the residuals are normally distributed. If epsilon is not the residual, then the third one is not correct.
It's not correct. Let's take a look at the lesson.
That's what I was,
I'm trying. My computer's trying to make me do.
so it's under 3. It says
Okay,
checking in the
well.
reading. It's in the reading. It's under 3. It says checking requirements for simple linear regression.
Excuse me.
Okay, are we still on 8? Sorry, my computer's doing weird stuff.
Yeah.
Okay. Trying to force me to do updates.
So under checking requirements of simple linear regression, it says the error term epsilon is normally distributed. But it doesn't say that epsilon is the residuals.
Right.
In number 3, the preparation, I was just reading through the answer stuff. It says, is there a linear regression between X and Y? And then it says, the error term E is normally distributed, yes. Made a QQ plot for the residuals, and the points are closer to linear. So the residuals and epsilon are 2 different things. So I don't know. I'm not going to mark it. I don't think it's so. And if I'm wrong, then I'll go back and change it.
I don't think it is either.
Because they're 2 different things.
Yeah, residuals and epsilon and error are different, right?
From what I can understand.
It's saying you made a QQ plot of the residuals and the points are close to linear.
See, but that was saying, the reason I read that was because the epsilon is saying is normal. But then they said when they do the QQ plot, the residual, now they're talking about something different, is linear. So they're using 2 different terms in 2 different ways. So I don't believe they're interchangeable.
Okay, so what's the next one?
I already moved on. What is B1, the estimate for the slope?
B1 is, oh, let's see.
12.695.
Yep.
I have.
Yeah.
And then it says, now with a 95% confidence interval for B1, input your answer for the lower bound and the upper bound.
Okay, so we need a lower bound
10.674.
0.674,
and the upper bound.
and the upper bound is 14.715.
Yep.
Based on the evidence using a level of significance of 0.05, what decision would you make regarding the hypothesis test for B1?
Where's R? R is 0.728.
So, I guess the question is, are we using, because based on this, because you're given a couple different options, and I don't see a p-value.
We use R, right?
So we have,
Yes.
so that would eliminate number 2, because that's a t, correct?
Well, there is a T on here,
Right.
and there is a p-value. However,
Oh, I do see the p-value.
yeah.
I don't know
So-
why I didn't see it.
We have to say, are we going to fail to reject or reject the null? Say they're not, one is equal and the other is not equal. So what is the null? Null for B1.
Okay, so it is using, I'm reading down the hypothesis test, and so it's going through and it says the test statistic following a t-distribution, we concluded the test for the slope. The information related to the slope is given in the second row under coefficients table and is labeled, because this was the crocodile, the head length. Looking across, we find the t is given as 35.588. That's a tremendously large value for t and indicates there's a lot of evidence against the null hypothesis. So our t value, we're basing this on our t value.
Well, it had, on this next one, it has a p-value that they are rejecting because it's less than 0.05, but our p-value is more than 0.05.
Somebody's feeding me.
So when theirs is less than 0.05, they're rejecting the null. So would we be failing to reject the null because it's greater than 0.05? Cheryl needs another invite.
Yeah, I'm trying to get back in that screen to send her another invite.
So weird.
I was going to read the second part on that because it talks about using a t statistic, and then remember the t has one number describing the degree of freedom, and then it goes into the p-value given for the sig, and that's what I couldn't find the information on. And
Well, like I said, this one is showing that the p-value for the whatever was less than 0.05, but here we're looking at our p-value is greater than a, which is 0.95. So fail to, because when it's less than the number, then we're going to have to fail to reject the null.
Yeah, I had Rose. Yeah. Sorry, guys, I lost you.
It's okay, I just got back. I need to look at it again, so.
Because it's that 0.05 again.
Where are we
The
at?
A is 0.05.
What number are you guys on?
9, 10,
Number-
11,
Well,
Number
12. I'm like trying to look.
We reject the null hypothesis since p-value is less than the level of significance.
I need to get in that test
Yes,
again. I hope I
both
didn't.
p-values are greater.
I brought Rose, honey. I brought Rose to me. Hungry right now. Okay, so you guys are on 12?
Correct.
All right. Let me pull up my.
Oh, this is our wonderful, how do you know when you fail to reject and you reject because it's la 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 la.
So on the preparation on 4, from preparation number 4.
Yep.
And it says, based on the p-value, do you reject or fail to reject the null? So the example that we were given is from those crocodiles, I guess.
Right?
And that one, the p-value was bunch of zeros, 508 is less than 0.05. Reject the null. That's why I'm wondering, because our p-value is greater than 0.05. So do we fail to reject?
We failed to reject it then. Yep, because our p-value is
8.4 and 3.3. Either way, they're both above.
but isn't the E -05, E -24, doesn't that mean there's a bunch of zeros in front of it?
No, after it. That was after. I don't remember.
Either way, even if you put a million in front of it, it would still be 3.3. So it would still be greater than 0.05 because we have a number on the left of the decimal.
So I think it's failed to reject. Because the p-value is greater than alpha. What do you guys think?
So you think it's 4?
I think it's
Because
4.
1, I don't even know how R correlates with 0.95.
Right, the only thing I see is either the T statistic or the P statistic.
They just want to see us squirm, that's all.
Yes. They succeeded.
I'm going to do 4. Well, and then it says, what decision can you make regarding B1? I got to read these all the way through. What decision can you make regarding B1? B1 is 12.965. Yeah, 3.31 is the p-value for B1, which is still greater.
Come on, baby. Come on. Up. Come on. You better turn.
You guys see my screen?
Okay, so one thing that he said last
Okay, look.
week that I thought was really informative in his,
Where did you find that?
It's above section 4.2 in the chapter.
did I miss something?
I'm showing my screen, and it says that the E negative 23 puts 23 zeros in front of the number. So that
Right,
would
but
make our p value 0.00 blah blah blah.
So then
So
we
it would make,
have to reject it because it's less than.
yeah.
It would be 3 then. Thank you.
Uh-huh.
Mhm.
so you think it's 3 then?
Yeah.
Yeah. Because that's one of those really strange things.
I think one of the best things that he said last week with the, for the next question. So the next question is, is there sufficient or not sufficient? He says, it's always restating, I don't know why you didn't tell us this from the beginning, it always restates the alternative hypothesis.
Yeah.
So we're going to say,
We're rejecting the null. So there is sufficient evidence to conclude that the slope of the regression line is not 0.
it's not 0.
So when you reject or you fail to reject, is it, I can't ever remember these. When you fail to reject, you have sufficient evidence.
I've got it written down somewhere.
Oh, I have it written down. I gotta look.
I have so many notes for this class. I don't know where everything is.
I know,
I
you
didn't
start
pull-
losing it all and it starts swirling together.
I wrote this down. I'm like, just because I always mess it up. If the p-value is less than 0.05, we reject the null hypothesis.
Right.
And then it says, and I didn't write, but the next thing I wrote was the p-value, if it's large, we fail to reject the null hypothesis. There is not enough evidence. So if it's smaller, there is enough evidence, or there's not a lot of evidence the larger the number.
So we're trying to restate the alternative.
And so we chose to reject
Reject.
the null.
Which would be equal to 0.
So that means that there is a lot of evidence. There is sufficient evidence to conclude
That it's not 0.
because if it's a large number, if we fail to reject, there is not a lot of evidence. If we reject the null, then there is sufficient evidence.
So just restating the alternative, which is always the not.
Right. That made it so much easier. I got those answers right on the last test after I learned that. I was excited.
Okay, so there is sufficient, you're saying there's sufficient evidence
Correct.
to conclude that the slope of the regression line is not 0?
Exactly.
Yeah.
And then we have one more.
Goody, the alligators, the crocodiles again, whatever they are.
Somebody likes crocodiles.
Oh, and I even wrote, and when I went through the assignment on this, the head and the body, which was going to be dependent and which was going to be.
The body is dependent on the head because
Isn't that what it's always been, is the body depends on the head size?
That's what I thought. Because they were measuring the heads, right?
So which is the dependent?
The body length is a dependent variable.
Hi, baby.
Well, let's pull it up. Let's see.
Hmm.
Y depends on X.
Which one are you doing now?
The crocodile.
50?
Number 14, just to make sure we're.
14. Yeah, I think they were measuring the crocodile heads.
Yeah, so I thought they were measuring the heads depended upon the head size.
Right, because the head would be a predictor of how long the body is. That would, because the head doesn't grow, the body grows.
Oh, I
Right?
gotta put in these numbers.
See, and it has right here, head length was used to predict body length.
Yeah.
There you go.
Is dependent upon the head length.
Right.
Okay, does this show the margin of error?
Oh. So head length is X or Y, sorry.
X.
Okay, I just want to make sure I put it in the right place because I botched that up on our other assignment, or when I did my first test, I put them backwards. Oh, silly machine.
Make sure you erase your other variables.
Yeah, that's what I was just doing.
Okay, margin of error is the upper minus the lower divided by 2.
The confidence interval?
Error.
Oh. Let me see.
That was another one he simplified.
Yeah.
Let me close that up.
But where is it?
Upper bound minus lower bound divided by 2.
And if the upper bound is a negative number, then we have to add them together.
Right, but you're only going to use the slope, right?
Well, we have to get the
Oh, yeah.
margin of error.
Right, but you're only going to use not B naught. You're only going to use B1, the slope.
Yeah.
Yep. So I get minus 0.4425.
Positive.
Yeah, mine's
You do?
positive too.
Really?
But-
Because
If you take 8.103 and you minus 7.218,
Well, I thought we were doing the lower bound minus the upper bound.
Well, it's
no, it's
upper
upper
bound.
bound minus the lower bound.
Upper bound minus the lower bound? Oh,
So it's 0.885.
so 0.885
Divide that
Divided
by
by 2.
divided by 2, sorry.
I almost forgot that too.
0.4425.
443, round up, 0.443.
Round up.
Roundup. It's a weed killer. Okay, so lower bound is 7.218.
Why did I think there were only 15 questions? All of a sudden we're like, we have more questions?
8.103.
Done though. This 18's our last one.
What can we say about B1? We are 95% confident that the confidence interval will contain a true value of B1.
The other
I
one
think
is
it's
just a
A.
chance. There's a confident and there's a chance.
Yeah,
I've never
chance doesn't work. It's either a confidence or
Or you're not confident. Yeah, I think it's A.
I think it's A.
Vote.
No?
Which one?
A is what I put. Doesn't mean it's right.
Yeah.
What I put. It's right.
Did we get them all?
No.
Oh, I submitted two.
I got 8 wrong and 6 wrong.
So well, 6, they're not in a linear pattern?
Nope.
What the heck?
And for 8, I left one unchecked. I'm not sure why. The middle one unchecked.
Well, we wondered about number 2 because it didn't read the right way, or was it number 3? I'm trying to load. Mine's not. So on.
So low for 8, did you check everything except the middle one? The residuals are not?
That's when my computer was messing up, so I wasn't hearing everything.
Well, we left the center one. We weren't sure. So.
Okay. So
But you got it wrong by missing that center one.
Yeah.
Huh, so I guess the residual, I mean, that's not what it says on the thing, but.
Epsilon must be the residuals?
We have to fix number 6.
And number 4 was wrong?
Number 8 and number 6.
Oh, 8 and 6.
Okay, but let's see I thought the residuals were in a linear pattern.
Yeah, so did I.
I know. So what is it? -40 and 25?
I don't know. I have to put them in again.
Because I think the residuals are the X's and Y's.
I have to put it back in, so let me look. Make sure you put them in the right way.
Yeah, they were twisted around.
So the score is.
There's nothing above them.
Or is C.
Oh, you know what's funny? If you look down the residuals, well, they're not all negative. Because the residuals are next to the X.
Yeah, so it'd have to be the
There's-
first one.
Yeah.
Because they're not all
So they're not all negative. Some of them are, but not all of them.
It's -40 to 25.
I'm not seeing that.
on 6.
Yeah, on 6, yeah. How are you seeing that, Lydia?
You have to look at the bin.
The
Those are
fourth
the
column
residuals.
over, it says residuals.
And they're not all negative numbers.
It says on number one is
Negative and positive.
0.95 and then negative 0.04.
So you have to sort these,
Negative
don't
40
you?
to 25. 40 and positive 25.
Okay, let me do that.
Oh, I missed one. What did I miss?
It won't let me.
I missed number 8. When I marked all of them, I missed it.
Okay.
So it cannot be, it has, the middle one can't be.
But
I'm gonna go back and put it how I have it. And if I miss it twice, then I miss it twice.
So I left the middle one blank and it was wrong.
Well, the other, I mean, you can read it word for word. That it says, checking requirements for simple linear regression. There are 5 requirements for a linear regression module. 1, there is a linear relationship between x and y. 2, the error term epsilon is normally distributed. 3, the variance of the error terms is consistent for all variables of x. Number 4, the x's are fixed and measured without error. 5, the observations are independent.
well, it says the x values are measured without error. It doesn't say fixed on the answers on the quiz. I don't know. So what?
So I'm gonna go back and look at it. I have to reload it.
So if x's are fixed, that means things that we can't check for, but we assume that they have taken place in the collection of the data. So it might be that one because the wording is not the same as the assumption, which says the x's are fixed.
I have to reload it.
And I don't see anywhere where it says the residuals are normally distributed.
And that's what I'm saying. I didn't see that anywhere. So maybe those 2 are not right. Let me, once I get to look at it again, I'm gonna reevaluate it. Let me just get there. It's crazy.
Okay, I only marked 3. And I put the observations are independent. The variance of the error term is constant for all values of x. And there's a linear relationship between x and y, and I got it wrong.
So which one did you get again?
I did the first
Sorry.
2 and the last 1.
And which ones did you do, Cheryl?
Hang on one second. I'm actually just going and re-entering my stuff.
You did
So
the
give me a
first
second.
2.
I'm on 8 now. So I originally had marked all of them. I'm going to read this again because I'm now on 8. it says, there is a linear relationship between X and Y. There is a linear relationship between X and Y. The variance of the error terms is consistent for all variables of X. The variance of the error term is consistent for all variants of X. It doesn't say anything about the residual. And then it says the X's are fixed and measured without error. So this just says the values are measured without error. It doesn't say fixed. So it's missing a word. And then the last is the observations are independent.
And that's word for word.
And that's word for word.
As
So-
is the first one, and as is
That's the second one.
the second one.
The first, second, and third are word for word for checking the requirements.
You mean first, second, and fifth one?
Correct.
Mark the first and the second and the third one, and it is incorrect.
You marked the first, second, I'm sorry, what did you mark?
The first, the second, and the fifth, the last one.
And it was
She got
wrong.
wrong. She got it wrong, though.
Yeah. I think we need to look at this. Scatter plot, given the scatter plot, residual plots, and QQ plots of the five, which of the five assumptions about linear regression are satisfied?
So, in the answer term, in the answer key, it says the error term is normally distributed. And then it says QQ plot of the residuals. So,
I think it's based upon that math stuff.
so maybe it's 1, 2, and 4.
But we need to look at the
1, 2, 3,
graph.
5. Right, because you check the error term is normally distributed by doing a QQ plot of the residuals. So maybe the residuals
According
are
to
normally
the
distributed.
So here's the, can you guys see that?
No, let me
Yes.
get that.
That's the QQ plot.
It's kind of a mess.
Mm-hmm. That's not linear.
Oh, I'm supposed to sort them. Huh.
Death eating.
There we go.
There. Normally distributed.
There we go.
We have the points on the scatter plot are close together in a hot dog shape. So yes, to number 1. Then they have the error term E is normally distributed, made a QQ plot of the residuals, and the points are close to linear. So yes. The variance of the error terms is constant for all values of X.
So I still got 8 wrong, and I did 1, 2, 3, and 5.
And it's still wrong.
It's still wrong.
So maybe we're reading, I don't understand. The software to create a scatter plot, use software, given the scatter plot, residual plot, and QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? So I guess it's not asking what the requirements are.
No,
It's
it's not
saying
asking.
based on these plots, what.
Oh, then maybe it would just be they're
No,
normally.
I'm sorry, I think I misread that. because I was reading what are the requirements, and it's asking, and that's why I wanted to check again, because it's saying, given the splatter plot, residual plot, and QQ plot, which of the 5 assumptions about linear regression are satisfied?
Then it would be
Right.
the third one.
So we just misread the question saying, I
Yeah,
thought it was
because-
asking about the requirements, and it's asking assumptions based on those plots.
Yep, and then it threw us off when it said check all that apply, but maybe there is more that apply. I don't know.
There would be more than one.
We know that there's a linear relationship, so maybe 1 and 3. One, 3, and 5, maybe.
That's what I'm putting.
So are you saying all the Y's are independent?
Yeah, they are, because there's, look at all the dots on there, they're all independent from one another.
But doesn't Y depend on X?
But they're still independent.
And it's not 1, 3, and 5 either.
Oh my goodness. Are you kidding? Wow.
So whatever it is, and I used my 2 tries, and I missed one question, and that's just going to be the way it is.
Yep.
So I'll have to read what the answer is to that, or maybe he'll go over it in his meeting.
Well, there's always one question.
So, or I'll go watch somebody else's video and see what they say. So. I'm going to stop the broadcast while we talk about our project.
Okay.